Welcome friends, in this I'm going to clarify some points on taking even roots of negative values. So let me go through this process a little bit. Imagine you have something like the square root of, say, 2 and this quantity is squared. Now perhaps you know in this case you can also do this as the square root. So the square root, remember, is the second root. There's a 2 index. And this is then 4, and this comes out to be positive 2. So that's simple. That's one way of doing it. Another way to do it is to say, for example, that you have 2 and then you have 2 squared, and in this case what you can do is you can just cancel these things. So what I mean by that is you can cancel this with this, and then you just end up here with a positive value of 2. In either case you get 2, whether you first do the exponentiation then the root, or you just cancel these off, you get 2. Now what happens in this case when you have, for example, the square root of something like negative 3 squared? It would be nice if you could simply just cross off and get negative 3 out, but it doesn't work like that. So go through the process. How do I know that? Well, if you first exponentiate under the root symbol, you're going to have the square root of 9, which is just equal to positive 3. Simple enough. So then if you try to do this on the other hand, take a look. So the square root of negative 3, and there's a 2 up here. And you first try to cancel these like this. And then you might conclude, okay, well, then it's equal to negative 3. Now we have a weird issue, which is we're beginning with the same thing, but we're getting two different results. We're getting negative 3 and positive 3. That can't be, obviously. So the correct way to do this, when you have this matching this, and this number here in the base is negative, is to do it as follows. You have the square root of negative 3. This quantity here is squared. Then you take this out. In other words, you can't cancel these, but when you do that, this has to come out in absolute value. In other words, it comes out as absolute value of negative 3, which then becomes positive 3. In other words, this value then matches this value right here. And you don't have this kind of weird thing going on. In other words, this, like this is not correct. We don't do that. Let me show you another couple examples with 8 other roots. So another example might look like the following. Imagine you have now the 4th root, say, of... let's see, make this 2 to the 4th, okay? So like this, basically, 2 to the 4th. That's a 2 here. One way to do it is you do the exponentiation. So it's going to be the 4th root of 2 to the 4th, which is 16. And that then just becomes positive 2. Again, notice this here matches this. The other way then to do it is you have 4 and you have 2, a positive base with the 4 up here in the exponent. In this case, you can just cancel these off and you end up with a positive 2. Simple enough. On the other hand, if you have now the 4th root of negative 2 to the 4th, again, if you do the negative 2 to the 4th, you're going to end up with a positive 16, right? A 4th root of positive 16, which is still equal to 2. So the final result of this has to be equal to 2. So the correct way to do it by canceling here is as follows. The 4th root of negative 2 raised to the 4th. And sure, if you cancel these in this case, like this, then be careful when you do this. Just take it in absolute value. So you end up with the absolute value of negative 2, which comes out as positive 2. So that this 2 here matches this 2 above there. So there's a general rule operating behind the scenes. Let me write down the general rule, might be of some interest. I'll squeeze that in here. Let me do that in yellow so it kind of gets differentiated from everything else. When n is an even number and you're taking the nth root of a to the n, it's equal to the absolute value of a. When n is even, like that. If it's positive already like this 2 here, no problem, 2 comes out. But if it's negative like this negative 3, then positive 3 will still come out by taking the absolute value of whatever this is. So that's why it comes out as a between absolute value bars for the reasons I've illustrated with these simple examples. So that is it, friends. Thank you. Please leave a like, please subscribe. I hope it's been helpful, insightful. I'll see you in another video.